Imagine a world where the Industrial Revolution didn't happen in the 18th century, but nearly 2,000 years earlier. Imagine a device, encrusted in the salt and grime of 2 millennia at the bottom of the sea, that contains gears so complex they wouldn't be seen again until the Age of Enlightenment. This is not a work of science fiction. It is the reality of the Antikythera Mechanism, the artifact that rewrote the history of human capability and remains the most baffling piece of impossible, ancient technology ever found. The Ghost in the Machine. The story of the Antikythera Mechanism, the story begins not in a lab, but in a storm. In the spring of 1900, a group of Greek sponge divers led by Captain Dimitrios Kondos were returning from Africa when a fierce gale blew them off course. Seeking shelter, they dropped anchor near the tiny, jagged island of Antikythera, situated between the Peloponnese and Crete. When the storm subsided, one diver, Elias Stadiates, donned his heavy copper helmet and lead-soled boots to check the seafloor for sponges. He descended 45 meters into the turquoise depths. But he didn't find sponges. He surfaced minutes later, trembling, his eyes wide with terror. He gasped to the captain that he had found a heap of dead, rotting people on the ocean floor. What Stadiates had seen were not corpses, but the ghostly, barnacle-encrusted bronze and marble statues of a massive Roman shipwreck. It was the greatest underwater treasure haul of the era. For a year, the divers worked alongside the Greek Ministry of Education to retrieve masterpieces of art. The Antikythera youth, exquisite glassware and jewelry. Among the piles of marble and bronze was a shoebox-sized lump of corroded green metal. It looked like a rock. For months, it sat in the basement of the National Archaeological Museum in Athens, ignored while historians fawned over the statues. Then, on a quiet afternoon in 1902, archaeologist Valerios Stais noticed something that shouldn't have been there. The rock had split open as it dried, revealing the unmistakable teeth of a gear wheel. The scientific community was horrified. According to every history book ever written, complex gearing of this nature, precision-cut, miniaturized, and differential, did not exist in 60 BCE. It was as if someone had found a jet engine in the tomb of a pharaoh. The clockwork mystery for the next 50 years, the mechanism remained a pariah. It was too advanced to be true. Some skeptics argued it must have fallen off a much later ship and landed on the ancient wreck by coincidence. But as the bronze continued to be cleaned and examined, inscriptions in Koine Greek emerged, dating the device firmly to the 1st or 2nd century BCE. In the late 1950s, a British physicist and historian named Derek de Solla Price became obsessed with the lump. He spent 20 years analyzing it, eventually using X-ray and gamma-ray imaging to look inside the corroded mass. What he found was a labyrinth. Inside that single box were at least 30 interlocking bronze gears. Price realized this wasn't just a tool, it was a computer. Specifically, a mechanical analog computer designed to calculate the motions of the heavens. The complexity was staggering. The device had a front dial and 2 back dials. By turning a hand crank on the side, a user could input a date. The gears would then whirl with mathematical precision, and the pointers on the dials would show the exact position of the sun and the moon in the zodiac, the phase of the moon, and even the timing of the next solar or lunar eclipse. The genius of the gears as technology progressed into the 21st century, so did our ability to see into the past. In 2005, the Antikythera Mechanism research project used high-resolution micro-focus X-ray tomography to create a 3D map of the fragments. The results were mind-blowing. The mechanism didn't just track the moon, it tracked the moon's elliptical orbit. The Greeks had figured out that the moon speeds up and slows down as it moves across the sky, due to its non-circular path. To replicate this, the ancient engineers used a pin-and-slot mechanism, 2 gears mounted slightly off-center, one driving the other via a pin. This allowed the device to mimic the variable speed of the moon. This level of mechanical engineering, using epicyclic or planetary gearing, was thought to have been invented in the 16th century. Seeing it in a device from 2,000 years ago was the equivalent of finding a smartphone in a Victorian-era chimney. But the device went further. It had a calendar that tracked the 4-year cycle of the Panhellenic Games. On a small dial, the names of the Olympiads were inscribed: Olympia, Pythia, Isthmia, and Nemea. This proved the device wasn't just for elite scientists. It was a cultural artifact, a way to sync the divine movements of the stars with the heartbeat of Greek society. Who was the architect? The question that haunts historians is, who built it? The shipwreck was a Roman vessel carrying looted Greek treasures, likely heading to Rome to celebrate Julius Caesar's triumphs. The craftsmanship points toward Rhodes or Syracuse. The name most often whispered is Archimedes. The legendary mathematician of Syracuse was known to have built spheres that mimicked the motions of the sun, moon, and planets. Though Archimedes died in 212 BCE, roughly a century before the ship sank, the Antikythera Mechanism might be a descendant of his work. A refined version of a tradition of Greek high-tech that we never knew reached such heights. Other scholars point to Hipparchus, the great astronomer of Rhodes, who discovered the precession of the equinoxes. The device uses his specific theories on lunar motion. Whether it was his hand or his influence, the machine represents the pinnacle of Hellenistic genius. The tragedy of lost knowledge, the Antikythera Mechanism, is not just a triumph, it is a warning. It represents a lost peak in human history. For reasons we still debate, the fall of the Greek city-states, the rise of the Roman Empire's focus on civil engineering over pure science, or the simple loss of specialized guilds, this technology vanished. The knowledge required to build such gears withered away. After the ship sank near Antikythera, the world would have to wait nearly 1,500 years for the first mechanical clocks in Europe to reach a similar level of complexity. The astronomical calculators produced during the Renaissance were, in many ways, no more advanced than what a Greek scientist held in his hands in 100 BCE. It forces us to ask, what else have we forgotten? If a device this sophisticated could be lost to the silt of the ocean floor, how many other impossible inventions are buried under our feet? The legacy of the machine today. The 82 fragments of the Antikythera Mechanism are kept in a climate-controlled room in Athens. They look like scraps of green, petrified wood, but they are the most important technical relic of the ancient world. The device serves as a bridge between the mythic past and the digital present. It proves that the ancients were not primitive people looking up at the stars in awe. They were mathematicians and engineers who looked at the universe and saw a clockwork mechanism that could be decoded, modeled, and held in the palm of a hand. As we look at our own rapidly evolving technology, AI, quantum computing, and space travel, the Antikythera Mechanism stands as a silent reminder. Technology is not a straight line of progress. It is a fragile flame, and sometimes that flame goes out, leaving only a few gears in the dark, waiting 2,000 years for someone to find them and wonder, how did they do it? If the Antikythera Mechanism was the computer of the ancient world, then our next story moves from the complexity of gears to the mystery of indestructible matter. While the Greeks were mapping the stars, other ancient civilizations were mastering the very building blocks of the Earth in ways that modern science is only now beginning to decode. Imagine a substance that can heal its own cracks, or a blade so sharp it contains structures we didn't invent until the 1990s. The eternal stone, the secret of Roman self-healing, concrete. If you walk into the center of Rome today, you can stand beneath the Pantheon. Built nearly 1,900 years ago, it still holds the record for the world's largest unreinforced concrete dome. If you built that same structure with modern high-grade concrete today, it would likely collapse or crumble within 150 years. Yet the Pantheon stands. Not a single piece of rebar supports it. It has endured earthquakes, fires, and the relentless march of time. For centuries, engineers asked the same question: what did the Romans know that we have forgotten? The mystery of the white chunks for decades. Scientists looking at Roman concrete noticed small, white, crumbly bits of mineral throughout the mix. These were called lime clasts. For a long time, historians dismissed them as a sign of poor mixing, a mistake made by a lazy Roman construction worker who didn't stir the mortar well enough. But in 2023, a team of researchers from MIT and Harvard realized something world-changing. The Romans weren't lazy, they were geniuses of chemical engineering. They discovered that the Romans used a process called hot mixing. by using quicklime, calcium oxide instead of slaked lime. They created a chemical reaction that made the concrete incredibly hot during the mixing process. This allowed the lime clasts to form a brittle, reactive structure within the walls. The impossible cure here is where the technology that shouldn't exist comes in. When a crack forms in modern concrete, it spreads until the building falls. But when a crack formed in Roman concrete, rainwater would seep in and hit those white chunks, the lime clasts. The water would dissolve the calcium, which would then recrystallize, filling the crack automatically. The wall would literally heal itself, becoming stronger over time rather than weaker. The Romans had invented self-healing infrastructure 2 millennia before the invention of the steam engine. While we struggle today with crumbling bridges and potholes, the Roman harbors in Italy are still standing, actually getting stronger because the chemical reaction with seawater creates a rare mineral called altobermorite that reinforces the concrete. The nanotech blades of the Crusades, Damascus steel while the Romans were perfecting the earth. The blacksmiths of the Levant and India were perfecting the forge. During the Crusades, European knights returned to the West with terrifying stories of Damascus blades. They claimed these swords could slice a silk scarf floating in midair, or cut through a European broadsword as if it were made of wood. The blades were recognizable by their swirling, water-like patterns known as damask. For 500 years, the secret of how to make these blades was lost. European smiths tried to replicate the pattern, but their swords were brittle and weak. They could get the look, but not the soul of the steel. The 21st century discovery in 2006, a team of German scientists used an electron microscope to look at a genuine 17th century Damascus blade. What they found shouldn't have been possible. Deep within the steel were carbon nanotubes and nanowires. Nanotechnology is considered a hallmark of the 21st century, the ability to manipulate matter at the atomic level. Yet, ancient smiths in India, who produced the woots, steel, and Syria, were using a specific combination of trace elements, like vanadium and manganese, and a precise cooling cycle to create these. Nanostructures. They didn't have microscopes. They didn't have chemical sensors. They worked by feel, the color of the flame, the smell of the forge, and the specific sequence of heating and cooling. By accident or by incredible intuition, they were performing molecular engineering over 1,000 years ago. When the specific mines in India ran out of the ore containing those trace minerals in the 18th century, the recipe stopped working. Because the smiths didn't understand the chemistry, only the ritual, the technology vanished overnight. The Dark Ages trap both the Roman concrete and the Damascus steel tell us the same haunting story as the Antikythera Mechanism. Civilization is not a ladder. It's a heartbeat. We like to believe that humans get smarter every year. But these technologies prove that we often reach incredible heights, only to fall back into the dark when a trade route closes, a library burns, or a specific resource runs out. The Romans had a maintenance-free world. The Damascus smiths had unbreakable steel. We lost both. It took us nearly 2,000 years to even understand why their concrete worked, and we still can't perfectly replicate the finest Damascus blades today with all our supercomputers. The mystery under the sand if we could lose the secret of self-healing stone and molecular steel. What else is gone? In the jungles of South America, there are ancient Terra Preta soils, man-made earth that is incredibly fertile and actually grows back even when harvested. In the deserts of Egypt, there are granite blocks cut with such precision that a laser couldn't find a gap between them. The more we look into the past, the more we realize that ancient technology isn't a collection of primitive tools. It is a series of forgotten masterpieces that challenge everything we think we know about our own modern superiority. We've moved from the clockwork precision of the Greeks to the chemical brilliance of Rome and the Damascus smiths. But if we look deeper into the very ground beneath us, we find a technology that doesn't just exist, it actually breathes. While Europe was entering the Middle Ages, a civilization in the heart of the Amazon rainforest was performing a feat of biological engineering that modern science is only now trying to replicate. The living earth, the mystery of Terra Preta. For centuries, the Amazon was viewed by Western explorers as a pristine wilderness. a vast, untouched jungle where only small, nomadic tribes could survive. The logic was simple. Tropical soil is notoriously poor. The heavy rains wash away nutrients, leaving behind acidic yellow clay that can't support large-scale farming. Without farming, there are no cities. Without cities, there is no civilization. But in the 1960s, soil scientists began finding something impossible: patches of deep charcoal black. Incredibly fertile soil in the middle of the barren jungle. They called it Terra Preta, black earth, the soil that grows itself, what makes Terra Preta technology rather than just dirt. When scientists analyzed it, they realized it wasn't natural. It was man-made. Thousands of years ago, the indigenous people of the Amazon created a recipe for soil. They mixed the yellow clay with a specific cocktail of biochar charcoal created at low temperatures, animal bones and fish remains, for phosphorus and calcium, nutrient-rich manure, broken pottery shards, which acted as apartments for beneficial microbes. This wasn't just fertilizer. It was a microbial incubator. Unlike modern chemical fertilizers that wash away after one rainstorm, Terra Preta stays fertile for thousands of years. But here is the impossible part. Terra Preta actually regenerates. Local farmers in Brazil have reported that if you leave a patch of this soil alone, it grows by about a centimeter a year. It is a living, breathing, biological technology that traps carbon in the ground and creates a self-sustaining ecosystem. The garden cities of the Amazon, the existence of this soil proves that the Amazon wasn't a wilderness. It was a massive, managed garden. This technology allowed for a civilization of millions, cities connected by raised highways, that vanished after the arrival of European diseases. We are looking at a lost agricultural internet that could solve modern world hunger and climate change, yet we still don't fully understand how they activated the soil's growth. The granite enigma, the precision of the serapeum. If the Amazonians mastered the soil, the ancient Egyptians mastered the very bones of the earth, granite. To see technology that defies explanation, you have to leave the Great Pyramid and go underground to the serapeum of Saqqara. Here, in a series of dark tunnels, lie 24 massive boxes made of Aswan granite. Each box weighs up to 100 tons. The lid alone is 30 tons. The precision problem mainstream archaeology tells us these were sarcophagi for sacred bulls, carved using copper chisels and stone pounders. But there is a massive engineering problem with that theory. One, the material. Granite is one of the hardest stones on Earth, 7 on the Mohs scale. Copper is a 3. You cannot cut granite with copper any more than you can cut a diamond with a butter knife. 2, the geometry. When engineers bring modern laser levels into the serapeum, they are shocked. The interior angles of these boxes are a perfect 90 degrees, with a precision of within 1,000th of an inch. 3, the flatness. The surfaces are so flat that they surpass the standards for modern optical laboratories. Even with 21st century CNC, computer numerical control, machines, creating a 100-ton box with that level of internal precision is an incredibly difficult multi-million-dollar task. How did a Bronze Age culture achieve it in pitch-black tunnels, using only hand tools? The tube drill mystery scattered across Egypt are granite blocks that show drill holes that look like they were made by a modern power tool. The spiral grooves in the stone indicate that the drill was biting into the granite with a feed rate, the depth it sinks per revolution, that is 50 times greater than what our best diamond-tipped drills can achieve today. It suggests that the Egyptians didn't just have better tools, they might have had a different understanding of physics. Some theorists suggest they used ultrasonic vibrations or sound frequency to soften the stone, making it as easy to cut as clay. While this sounds like science fiction, we have no other way to explain the physical marks left in the rock. The pattern of the impossible, whether it is the self-healing concrete of Rome, the nanotech steel of Damascus, or the self-growing soil of the Amazon. A pattern is emerging. We often view history as a slow climb from dumb to smart, but these artifacts suggest a different story. They suggest that ancient humans were just as brilliant as we are, perhaps more so, because they worked in harmony with the natural properties of matter, rather than just trying to blow things up or burn fuel. They didn't have electricity, but they had chemistry. They didn't have computers, but they had mechanics. They didn't have the internet, but they had a deep ancestral knowledge of materials science that we are only now starting to relearn. The question that remains the real mystery isn't that these things existed. The mystery is, where did the knowledge go? How do you lose the secret to making soil that feeds millions? How do you forget how to cut granite like butter? Every time a civilization collapses, we lose more than just buildings. We lose the software of human survival. As we look toward the future, toward Mars, toward AI, we must look back at the Antikythera Mechanism or the Serapeum boxes and realize that we are not the first high-tech species to walk this earth. We are just the latest. To conclude this journey through the impossible archives, we move from the heavy granite of Egypt to something far more delicate, yet equally mind-bending. The mastery of light and the defiance of chemistry. The chameleon's chalice. The Lycurgus Cup in a dimly lit room in the British Museum sits a 4th century Roman glass chalice known as the Lycurgus Cup. At first glance, it appears to be a beautiful, albeit standard, piece of jade green glass. But when you shine a light through it from the inside, something impossible happens. The cup instantly turns from dull green to a vibrant, glowing blood red. The 4th century nanotech for centuries. Historians thought this was some kind of magical trick or a freak accident of the glass-making process. It wasn't until 1990, when scientists examined fragments of the glass under a high-powered electron microscope, that they realized the Romans had been practicing quantum physics 1,600 years before we even had a name for it. The glass was impregnated with particles of silver and gold, ground down until they were only 70 nanometers wide. To put that in perspective, a single grain of sand is about 1 million nanometers wide. The Romans had discovered that at this specific nanoscale, gold and silver don't behave like metals. They interact with light through a phenomenon called surface plasmon resonance. This is the exact same technology we use today in high-end medical sensors and modern fiber optic cables. How did a Roman artisan, working over a charcoal fire, manage to grind precious metals to a scale so small that only an electron microscope can see them? And more importantly, how did they get the ratio so perfect? If they had used even a fraction more gold or silver, the effect would have failed. This wasn't an accident. It was a lost branch of optics that died with the empire. The pillar that defied rust. The iron pillar of Delhi, our final stop, takes us to the Qutub complex in Delhi, India. There stands a solid iron pillar, 7 meters tall, forged over 1,600 years ago. In the humid, monsoon-prone climate of India, an iron structure of this age should have crumbled into a pile of rust centuries ago. Yet the Delhi iron pillar remains pristine, its surface smooth and uncorroded. The mist-tie layer for a long time, Western scientists thought the iron was simply pure. But when they finally analyzed it, they found the opposite. It was dirty iron, full of high levels of phosphorus. The ancient Indian smiths had developed a specific technique called forge welding that created a thin, protective layer of mesawite, a complex compound of iron, oxygen, and phosphorus over the entire surface. This layer is essentially a biological chemical shield. While modern scientists struggle to protect bridges with expensive paints and galvanization that only lasts a few decades, these ancient metallurgists created a maintenance-free material that has survived 16 centuries of rain, wind, and pollution. Like the Roman concrete, it is a technology that doesn't just resist the environment, it uses the environment to stay strong. The grand conclusion, the great forgetting, we often speak of human history as a great leap forward. We imagine our ancestors as primitive, slowly dragging themselves out of the mud until we finally invented the steam engine and the smartphone. But the stories of the Antikythera Mechanism, the Lycurgus Cup, and the Roman self-healing concrete tell a different, more humbling story. History is not a straight line. It is a series of peaks and valleys. We are currently living on a high peak, but the ruins below us prove that we have reached these heights before, only to fall back into the dark ages, where the most advanced secrets of the era are forgotten. Why did they lose it? Technology requires 3 things to survive: 1. Resources. When the mines for Woot's steel ran dry, the Damascus blade died. 2. Trade. When the Roman Empire collapsed, the hot-mixing concrete recipe was buried under the rubble of a broken economy. 3. Knowledge transfer. When the Library of Alexandria burned or when specialized guilds were wiped out by plagues, the software, the human knowledge, was deleted. The lesson for us: these out-of-place artifacts are not just curiosities. They are a mirror. They show us that the ancient world wasn't a world of magic, but a world of different genius. Our ancestors didn't have electricity, so they mastered the chemistry of the earth and the mechanics of the stars. The Antikythera Mechanism reminds us that we can lose our most complex tools. The Roman concrete reminds us that we can forget how to build things that last. The Damascus steel reminds us that we can forget the very secrets of the matter we hold in our hands. As we look at our own digital world, stored on fragile servers and powered by a grid that could fail, the impossible technology of the past stands as a silent warning. Civilization is a gift that must be maintained, or it will be reclaimed by the sea and the sand, waiting for the next cycle of humans to dig it up and call it impossible. The end of the record, the story of ancient technology that shouldn't exist, isn't really a story about machines. It's a story about us, our brilliance, our fragility, and our incredible ability to touch the stars, forget how we did it, and then try to reach for them all over again.